How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at 3.7 practice problems, limiting reactants and percent yield. So these are going to be some of the longer type of problems. So number one, the combustion of propane produces CO2 and H2O shown in the balanced chemical equation below. There it is. It's balanced for you. How many moles of H2 are produced in a reaction of 2.5 moles of O2 and 4.6 moles of C3H8? So the problem here is we don't know which one we have extra of. So we know the reactants are this O2 and this C3H8. We're going to have excess of one, and we don't know which one it is. So if I'm starting to think about this, the first step I'm going to have to do is figure out my limiting reactant. So which one of these am I going to run out of first? Because you need to use that to predict how much you'll be able to make, right? So once I got my limiting reactant, then I can figure out, based on that, what should be my theoretical yield. You know, if I have like 6 hot dogs, but I only have 4 buns, I can only really make 4 hot dogs, you know? So which one of these things am I going to run out of first? So in order to do that, I'm going to reread the problem. I'm going to circle things and I'll show you, right? So first thing, 2.5 moles of O2. I'm going to circle that. 4.6 moles, I'm going to put a box around that, of C3H8. I'm going to put a box around that. And then how many moles of H2O? Well, since this is another thing, I'm going to put a triangle around that. So I got 3 different things I'm focused on. The CO2, not interested in this problem. So limiting reactant, I got to look at the 2 things that I'm starting with, right? So I got to look at my ratio between the propane, C3H8, and the oxygen. Right? It's a 1. Propane needs 5 moles of oxygen to react with. So now I'm just going to pick one of those things. I'm going to go, all right, like why not O2? I'm going to use the oxygen. So if I use 2.5 moles of O2, how much propane would that react with? So now I can cross multiply and divide, and I get X equals 0.5 moles of propane. So if I were to react all of the O2, I would need this much propane. How much propane do I have? Oh wow, I got 4.6 moles of propane. I have extra propane, which means I'm going to run out of oxygen. This means my limiting reactant is my oxygen. I'm going to use up all of the oxygen, whereas the propane, I'm going to have leftovers. So I did that first part. I figured out my limiting reactant. Now I got to figure out my theoretical yield. So I'm going to ignore propane from now on because oxygen is my determining factor. So now I need to know, well, what is my ratio between oxygen and the thing we're interested in, H2O? Well, it is a 5:4 ratio. So let me start. I have 2.5 moles of O2. My balanced chemical equation tells me that for every 5 moles of O2, I'm going to be able to produce 4 moles of H2O. My moles of O2 are going to cancel out. Now I got moles of H2O, and that's the unit it wants me to solve for. So now I can just plug and chug. And when I do that, I end up with 2.0 moles of H2O. That's how you do that problem. All right, next problem 2. A 3.82 gram sample of magnesium nitride is reacted with 7.73 grams of water, shown by the chemical equation below. And there it is. It's already balanced for us, so that's great. It produces this much magnesium oxide. Calculate the percent yield. All right, if I'm trying to get percent yield, right, if I'm gonna end with percent yield, I need to know what my theoretical yield is going to be. If I need to figure out my theoretical yield, I need to know which one of those reactants I'm going to run out of first. So this is going to be my roadmap. I'm going to start with figuring out my limiting reactant so I can figure out how much I should be able to make, my theoretical yield, and then I'm going to compare that to what I actually made to figure out my percent yield. So let's start. First, I need to have moles, right? So if I'm saying 3.82 grams of magnesium nitride, reacted with 7.73 grams of water, I need to convert those to moles because the balanced chemical equation is in terms of moles. It's saying 1 mole of magnesium nitride will react with 3 moles of H2O. So I can't just use grams. So let me do that. I got, let's see, 3.82 grams of Mg3N2. If I times that by its molar mass, I got 1 mole is 100.95 grams, which tells me I get 0.0378 moles of magnesium nitride. So now if I do H2O, I have 7.73 grams of H2O. Again, gram formula mass for H2O, well, 1 mole of it is that 18.02 grams. So grams cancel out. When I plug and chug, I get 0.429 moles. So now I can take a look to figure out which one I'm going to run out of first. So I know that the ratio between magnesium nitride and H2O is a 1:3 ratio. So just pick one of them. I'm going to go with magnesium nitride, right? So if I had 0.0378 moles of magnesium nitride, how many moles of water would that be? Cross multiply and divide, X equals 0.1134, and that's going to be moles of H2O needed. So if I were to react all of my magnesium nitride, this is how much H2O I would need. How much do I have? Well, I got more than that. So I'm not going to run out of H2O, which means that magnesium nitride is my limiting reactant. So now that I got my limiting reactant, I can go figure out my theoretical yield. So if I started with 3.82 grams of magnesium nitride, and I know the gram formula mass for that is 1 mole is 100.95 grams. I got my grams canceling out. So now, I don't know why I'm putting double dots. There you go. Now I'm going to multiply that by the ratio from the equation. So I know 1 mole of magnesium nitride will react with 3 moles. Oh, I'm sorry. I don't care about H2O anymore. I'm trying to figure out for MgO. Right? So MgO is over here. 1 magnesium nitride is going to give me 3 moles of MgO. Moles of magnesium nitride cancel out. Right? Now I just got moles of MgO, and now I need to times that by the gram formula mass of MgO. So 1 mole, oh, I just got to put 1 mole on the bottom, and the mass of MgO is, I got to look it up, I'm sorry, 40.31 grams. Moles of MgO cancel out. When I finally plug and chug and do all that, I get 4.57 grams of MgO. So this is my theoretical yield right here. This is what I needed, because now I can go to my percent yield. I know percent yield is going to be equal to what I actually got over my theoretical yield times 100, because it's a percent. So what I actually got was 3.60 grams from the problem up here, divided by what I should have been able to get theoretically, 4.57 grams, times by 100. And I plug and chug, and I get 78.8% as my final answer. These problems are long and obnoxious because it's really 3 problems, right? We got to first figure out what's my limiting reactant. Then what's my theoretical yield? Then, and only then, can you figure out the percent yield. 3. What is the theoretical yield in grams of NH3 that can be produced by the reaction of 1 gram of nitrogen and 3 grams of hydrogen in the equation below? Notice that it's not balanced. So the first thing we're going to have to do is we're going to have to balance it. So a little review, take inventory, write the same order on both sides. I have 2 nitrogen and 2 hydrogen. On this side I have 1 and 3. So let's try to fix the nitrogen. I put a 2 in front. Now I got 2 nitrogen, but I also changed hydrogen to be 6. So if I need 6, I got to put not a 6 in front, a 3 in front of the H2. So I end up with 6, and now it's all balanced, right? So I got my balanced chemical equation. Thank goodness. Only now can I begin. All right, so now I can go, all right, well, what is my limiting reactant? And then once I know that, then I can get my theoretical yield. So I got 1 gram of N2, and I got 3 grams of H2. So grams isn't helpful, so I need to get moles, right? So let me convert them to moles, right? I do 1.0 grams of N2 times by 1 mole over, is that 28.02 grams, and I end up with 0.03569 moles of N2. I got to do the same thing for hydrogen. I got 3.0 grams of H2 times by 1 mole of H2 over 2.02 grams of H2, and I end up with 1.485 moles. So now once I got that, now I can start to figure out my limiting reactants. So I know for N2 to H2, my ratio is going to be a 1 to 3. So why don't I just go with N2? If I have 0.03569 moles of N2, how much H2 would I need to react with that? So cross multiply and divide, and you get X equals 0.1068 moles of H2 needed. Well, how much do I have? I have extra. I have more H2 than I need, so that tells me my N2 is going to be what I run out of. So that's my limiting reactant. So my limiting reactant is N2. So now I can figure out my theoretical yield based on my N2. I can ignore my hydrogen. I can even cross it out so I don't get confused. So if I have 1 gram, 1.0 gram of N2, I can multiply that again by 1 mole over 28.02 grams. So I end up with moles of N2. Then I go to my balanced chemical equation. Well, I know the ratio is for every 1 mole of N2, I can make 2 moles of NH3. Now my moles of N2 cancel out. I got moles of NH3, but they want it in grams, and the problem said in grams. So I got to times that by the gram formula mass. I know 1 mole of NH3, I got to put it on the bottom so it cancels out, is 17.03 grams. So moles of NH3 cancel out. I'm left with grams of NH3. Now I can just plug and chug, and I get 1.2 grams of NH3 is my theoretical yield. All right. 4. What is the percent yield of a reaction where 22.05 grams of propane reacts with excess oxygen to produce 38 grams of carbon dioxide? This one's a real pain, because before I can do anything, I got to figure out what is this equation even going to look like. So they tell me C3H8 reacts with excess oxygen to give me carbon dioxide. And this is a combustion, so you know the other missing thing is H2O. So now I got to balance. All right, CHO. CHO. I got 3, 8, and 2. I got 1, 2 hydrogen, but I have 3 oxygen. I got 2 right here, and then I got 1 over there. So let me fix the carbons. I put a 3 in front of that CO2. I end up with 3 carbons, but I also changed the number of oxygen. Now I have 7, because I have 3 times 2 plus this one over here. I fixed carbons. I messed up oxygens even more. Hydrogens. Why don't I fix that? I put a 4 in front of this H2O. Now I have 8 hydrogens, but I also changed my oxygens. Now I have 3 times 2, which is 6, plus 4 more oxygens, gives me 10 oxygens. So now I fix my oxygens, I put a 5 in front of that O2. Now I have 10 oxygens, everything's good. I balance it all. I can get rid of all this work now. Erasing. So now that I got my balanced chemical equation, now I can start to try to answer their question. They want percent yield. So if I'm trying to get percent yield, I need to first know my theoretical yield, which means I need to know my limiting reactant. So this, again, is my roadmap. Limiting reactant, so I can figure out my theoretical yield, so I can figure out my percent yield. So what's great about this problem is they tell us that it's an excess oxygen, meaning that we're not going to run out of oxygen. We know propane is our limiting reactant, so we don't have to worry about that. So let's figure out our theoretical yield. We start with 22.05 grams of propane. I got to convert that to moles. So I know 1 mole of C3H8 has a mass of 44.11 grams. So grams cancel out. I'm left with moles of propane times. All right, well, I can look to my balanced chemical equation. I'm looking at propane and they're asking me about carbon dioxide. So I know for every 1 mole of propane, which I put on the bottom so it'll cancel out, I will get 3 moles of CO2. Moles of propane cancels out. Now I got moles of CO2, but they want the percent yield and they give us grams, so we got to get grams. So 1 mole of CO2 has a molar mass of 44.01 grams. Moles of carbon dioxide cancel out. I end up with grams of CO2. Now I can plug and chug, and I get 66.00 grams of CO2. So that was my step 2. Step 3 is percent yield, right? So percent yield is equal to what we actually got experimentally, what we could have gotten, or divided by what we could have gotten, times by 100. So what we actually got was 38.0 grams, and I get that from the problem up here, divided by what I could have made, 66.00 grams, times by 100. We plug and chug, and we get 57.6% as my final answer. Moving on, it's like a marathon. If 2352 grams of iron sulfide is reacted with that many grams of O2 according to the equation below, how many grams of Fe2O3 would be produced? And again, here's another one where they're being a pain. They're making you balance it first. Right, so let me do that first. Create your inventory, do the same thing on the other side and in the same order. I got 1 iron, 2 sulfur, 2 oxygen. On this side, 2 iron. I have 5 oxygen from the 3 and the 2, and 1 sulfur. So let me fix one at a time. I put a 2 in front of this. Nope, that's not where I put a 2. I put a 2 in front of this one. Changes my iron to 2, but also changes my sulfur to 4. And then you go, all right, well, let me put a 4 in front of this sulfur. And I change my sulfur to 4, but I also change my oxygen. Now I have 4 times 2 is 8, plus 3 is 11. Oh no, what am I going to do? I got to count by 2 to get to 11. This is what I recommend doing, a little trick. Let me do 11 halves. But Mr. Donnie, you can't have a fraction as a coefficient. You're absolutely right. So how do I get rid of a fraction? Well, I times everything by 2. So this 2 becomes a 4. This 11 halves becomes 11. This 1 becomes a 2. And this 4 becomes an 8. So now you can go back and you can check to make sure that everything is still balanced. Well, how many irons do I have on this side? 4. I have 8 sulfurs, and I have 22 oxygens. Let me check this side. This side, I have 4 irons. This 2 times 2. I have 8 sulfurs. Awesome. I have 2 times 3 oxygens is 6, plus 8 times 2, which is 16, which gives me 22. Everything's all balanced now. I did a good thing. So now that I got my balanced chemical equation, I can follow the pattern of first I got to figure out what my limiting reactant is, and then I can figure out my theoretical yield, because that's what they're asking, how much would be produced. So first step, convert all this nonsense into moles. So 2352 grams of FeS2. I'm gonna have to times it by 1 mole of that stuff over, I think it's 119, can't read my own handwriting, 0.99 grams, and I end up with 19.60 moles of FeS2. I have to do the same thing for O2. I have 1408 grams of O2 times by 1 mole of O2 over 32.00 grams, and I end up with 44.00 moles of O2. So now that I got moles, I can figure out which one I'm going to run out of first, right? So if I'm looking at FeS2 and O2, it's a 4:11 ratio. So let me just pick one. I'm going to go with FeS2. If I had 19.60 moles of FeS2, how much oxygen would I need? So now I can cross multiply and divide, and I get 53.9 O2 needed. Well, let me look at how much I got. Well, I only got 44.00 moles, and I need more than that. So that's telling me that oxygen is my limiting reactant. I'm going to run out of oxygen before I do the other stuff. So now, second step, my theoretical yield. I go, all right, well, I can ignore everything about the iron sulfide. I only care about the oxygen. I have 1408 moles of, or not moles, grams of oxygen. I know I'm going to need moles, so I put 1 mole over 32.00 grams. My grams cancel out. I got moles of O2. And now I can look at my balanced chemical equation. They want to know about Fe2O3 and O2. Well, I know that for every 11 O2, I can make 2 Fe2O3s. So my moles of O2 cancel out. Now I got moles of Fe2O3. And then the last step is to get it in grams because it wants it in grams. So I'm going to continue it on over here. I know 1 mole of Fe2O3 has a mass of 159.7 grams of Fe2O3. So now I can pick up my calculator, I can plug and chug, and I get 1278 grams as my theoretical yield. All right, last question, 6. Sulfur and oxygen react in a combination reaction to produce sulfur trioxide, an environmental pollutant shown by the balanced chemical equation below. In a particular experiment, the reaction of 1 gram of sulfur and 1 gram of oxygen produced 0.8 grams of SO3. What is the percent yield for this experiment? So, all right, so let's work backwards. If I want the percent yield, I need to know what my theoretical yield is, which means I need to know what my limiting reactant is, which means I need everything in terms of moles, right? So this is going to be kind of my roadmap for how I'm going to solve this problem. So first, let me convert everything into moles, right? So 1 gram of sulfur, I divide by its gram formula mass, is at 0.031 moles. 1 gram of oxygen, I divide by 16.00, and I end up with 0.031 moles as well. So let me figure out my limiting reactant. Well, based on the equation, it's for sulfur to oxygen, the ratio is a 2 to 3 mole ratio. So let me just plug in sulfur, right? So I get 0.031 moles of sulfur will need how much oxygen. So now I cross multiply and divide, and I get X to equal 0.0465 moles of O2. But we only have 0.031. So that tells me O2 is my limiting reactant. I'm going to run out of that first. I have less than what I need. All right, so next step, percent yield, or theoretical yield. All right, well, if I have 1 gram of O2, let me convert that to moles. 1 mole is 32.00 grams. And now let me look to my balanced chemical equation for the ratio between O2 and the thing I'm interested in. In this case, it's going to be SO3. So I know that 3 moles of O2 will give me 2 moles of SO3. Now my moles of O2 cancel out, and my grams already did, but I didn't cross them out. So now I got moles of SO3. So my last step will be to go, hey, 1 mole of SO3 is 80.07 grams of SO3. Again, the units are telling me which one should go on top and which one should go on bottom. If I'm trying to cancel out moles of SO3, if it's on top, I need to put it on bottom in my conversion factor. So now I can just plug and chug, and I get 1.7 grams of SO3 as my theoretical yield. Now my percent yield is what I actually got, which they said was 0.8 grams, divided by what I could have gotten, 1.7 grams, times by 100. And when I do that, I get 47% as my percent yield. Cool, I hope you found that helpful. It was a bit grueling. Okay, bye.